Hello and welcome students. In statistics under home learning at my YouTube channel, we are studying chapter number 3, that is linear regression. As we all know, regression is a mathematical functional relationship between the two variables by which dependent variable can found out with the help of independent variable. There are two variables, one is known variable, one is unknown variable. We can find the unknown variable with the help of known variable. But now the question arises in our mind, whenever we find the unknown variable, value of unknown variable, whether it is correct or not, how can we judge it? See, in regression analysis, as we all know, we did the different types of sums. We have to find the regression line. And my dear friends, regression line can find with the help of 3 steps. The first step is to find the regression coefficient, that is denoted by b, small b. The second step is to find the constant. Constant is denoted by a. And the third step is to find the regression line. Regression line is denoted by y cap. We did the different types of sums. When x bar and y bar are integer, we take the sums of that particular type. Then the value, digits of x and y are small, less than 30. We also take the sums of that type. Then we take the questions, practice sum of UV method or shortcut method. The digits are big, the question is given provided in the point. Then we take the sums in which the UV method is there and we also apply Cx and Cy. It means when we divide all the digits, then we have to apply Cx means all the digits of x divisible by one particular point, that is called Cx. And Cy means all the digits of y particularly divided by some particular digit, that is Cy. We take such sums also. Now, after that we take the sums of different, like we take the sums in which short type of sums are there when covariance xy is provided. Then also we do the sum, we did the sums, and coefficient, correlation of coefficient r is provided. Then also how can find the regression line, that also we do. Now, what is today's topic of video lecture? Today we take a sums of coefficient of determination. Now the first question arises in our mind, sir, what is coefficient of determination? As we all know, regression is a functional relation between the two correlated variables, and it is used to estimate the value of dependent variable from some given value of independent variable. The coefficient of determination is a measure to find the reliability of such particular estimation. See, regression is a one type of estimation, but this particular regression is reliable or not. Whether it is reliable or not, how to check the reliability of this particular regression? The tool to check the reliability of the particular regression is called coefficient of determination. I repeat this, the tool by which we can check the reliability of particular estimation under regression analysis is called coefficient of determination. The coefficient of determination is denoted by capital R square. Capital R square. This is the sign of coefficient of determination. Sir, how can we find the capital R square? Capital R square is equals to small r square. The simple meaning of this is that, my dear students, that we have to find the value of R. Sir, R means previous chapter number 2, correlation coefficient. Whenever we find the value of correlation coefficient, that is R, we have to do the square of that particular answer. If the answer of R square, is nearer to 1, then we have to write the conclusion that it is reliable estimation under regression analysis. And if suppose the answer of R square is nearer to 0, then the regression cannot reliable. The regression cannot reliable. It means we have to find the value of R square. If the value of R square comes nearer to 1, answer comes nearer to 1 means if answer is between 0.50 to 1, 0.5050 to 1, it is called nearer to 1. And if it comes nearer to 0, 0 means between 0 to 0.49, then we have to write at last in conclusion that it is not reliable estimation. So, coefficient of determination, my dear friends, is the reliability check of regression analysis, whether the regression analysis is reliable or not. So today we take one sum of coefficient of determination. Please open your textbook, page number 138. Page number 138. Of textbook. The following table shows the experience of technicians in years employed at various companies and their monthly salary in 1,000 rupees. Two things are provided: experience, which is called X, and the second is monthly salary, which is Y. The experience data is provided 12, 8, 16, 20, 5, 4 and 10. While the monthly salary data is provided 22, 15, 25, 30, 12, 24 and 20. These two columns are provided. The question is calculate the coefficient of determination and check the validity of the linearity assumption of regression between the years of experience and the monthly salary. So my dear students, we can apply here UV method or XY method or X minus X bar method. We have to find simply the R square. R square means we can find the value of R, then we do the square. Or directly into bracket, we write the whole formula of R, that is correlation coefficient, and then we do the square of it. So, here in this particular sum, I apply the XY method of correlation coefficient. You all are remember it because in correlation coefficient second chapter we recently studied it. For xy method we have to prepare additional 3 columns: xy, x square and y square. Additional 3 columns we can prepare. First column is xy, then next column is x square, and the another column is y square. 3 additional column here we prepare: xy, x square and y square. xy means multiplication of the both column x and y. 12 into 22, 264, 120, 400, 600, 60. It is 336 and 200. The x square is 144, then 64, 256, 400, 25, 196 and 100. X square, the column square of the column of x. Now y square means the square of the column of y. 484, 225, 625, 900, 144, 576, 400. As you all know, we have to do the total of all these square. All the columns, we have to do the total because it is required in the formula. Total of x, 85. Total of y, 148. xy, 1980. X square, 1185. And y square, 3354. Raw material is ready, my dear friends. Now we have to put the values into the formula. Coefficient of determination. Here I write the formula of coefficient of determination. The formula is capital R square. Capital R square is actually R square. The formula we put is n sigma xy minus sigma x into sigma y upon into under root n sigma x square minus sigma x the whole square into second under root n sigma y square minus sigma y the whole square. We put the square of the whole big bracket because it is here we have to find R square. That's why the square of the whole bracket. Now n is 1, 2, 3, 4, 5, 6, 7. The value of sigma xy is 1980 minus sigma x 85, 148 sigma y. Sigma x square is 1185 minus sigma x the whole square, so 85 square 7 3385 3354 not 85 sir 3354 the total of sigma y square, 148 the whole square. Now we do the simplification. 13,860 minus 85 into 148, that is 12580 upon 8295. That is the multiplication of 1185 into 7. 8295 minus 7225 into second under root 23,478 minus square of 148, that is 21,904. Finally, we got 1280, the square, and in upon we have 1070 and 1574. You all can do with your calculator simplification. The final answer comes 0.972 is the final answer. You can do it with your calculator. The main important aspect is that here the answer of coefficient of determination, capital R square, is 0.97. As I explained you earlier when I begin this video lecture, that if the answer of coefficient of determination is nearer to 1, then it is reliable, or we can say the estimation of regression is reliable. We have to check the reliability, and if the answer is nearer to 0, then it is not reliable. So my dear friends, to get full marks, you have to write at last, like they write in the book, the value of R square is very nearer to 1. You can see in the textbook, page number 139. So we can say that the linearity assumption of regression, this you have to write this line compulsorily at the end of your sum. Linearity assumption of regression between the years of experience and the monthly salary is valid. So as per our tradition, at last we have to do the fast recap of the whole particular sum. The topic is coefficient of determination. Two columns are provided, x and y. We have to find the value of r, so we prepare additional 3 columns, xy, x square and y square. Now 3 additional columns we prepare. After preparing all the 3 columns, we do the total xy, x square and y square. Then we put the formula for r square like this. Capital R square is equals to small r square. Same the formula of xy method is there, n sigma xy minus sigma x into sigma y upon into under root n sigma x square minus sigma x the whole square into second under root n sigma y square minus sigma y the whole square. We put all the values into the formula. In place of n, there are 7 pairs, so we write 7. After preparing after putting the values, we do the simplification of that particular r square. At last, finally, the value of r square comes 0.9728. You can do because 1-2 steps, either I leave the 1-2 steps, but you can able to do with your own calculator, all the calculation. Already we learn it in a linear correlation chapter, so it is possible for you to do. Now, after find out the value of r square, capital R square or small r square, when the value of r square is nearer to 1, here the value of r square is 0.9728, so it is nearer to, very nearer to 1. So we can write that the assumption of the variability of the reliability is valid, or we can write that the linearity assumption of regression between the years of experience and the monthly salary is valid here. So this is the practice sum for coefficient of determination. I am confident that you all are able to understand this particular sum. We do further practice of coefficient of determination in next video lecture also. In next video lecture, I take the sum when we apply the UV method, shortcut method, and also specifically when division is there. Because of division, CY and CX, we have to apply the CY as well as CX. CY means class interval of Y and CX means class interval of X. So such sums we take in the next video lecture. Thanks for your cooperation. Thank you, students.